Part A. Find the maximum voltage that can be applied across a 250 ohm half-watt resistor without overheating it. Part B. With the voltage found in Part A, how many electrons would flow past the resistor in a minute? So here we have 250 ohms, that's the resistance. 1/2 watt, that's the power. And we want to find the voltage. Which equation relates those three? That would be the power equation, that is P equals to V squared over R. The power is 1/2, the voltage is what we're looking for, and the resistance is 250. So the voltage is square root of 125, which gives us 11.2 volts. So that's the answer in Part A. For Part B, we're looking for the charge flow, which means we have to find the current first. We can use V equals to IR, the Ohm's law, or we can use a different power equation to find the current. I'm just going to use the Ohm's law. 11.2 equals to I times R, 250. So this will give us a current that is 0.0447 amps. And amps means coulombs per second. So this means 0.0447 coulombs of charge flows by every second. And we want the number of electrons in a minute. So in a minute, 60 seconds, the charge that flows by would equal to the 0.0447 times 60. And this will give us the charge flow, and that's 2.68 coulombs. Or we can say the current by definition is delta Q over delta T. So if we want to find the charge flow, we just have to multiply the current by the time, and that's what we did. But this is not the answer yet, because what we want is the number of electrons. Since the total charge flow is 2.68 coulombs, and 1 electron gives us 1.6 times 10 to the negative 19th coulomb. So if we divide the total by how much each gives us, we will get the number of electrons, which is 1.68 times 10 to the 19th. And this will be the answer for Part B. Or, of course, if you want, you can use the equation for charge quantization. Q equals to N times the elementary charge. So if we want the number of electrons, we just have to divide the charge by the elementary charge, and that's what we did over here. Here are some resistors with various power or wattage ratings. A rating of 1/2 watt means the resistor can dissipate 1/2 joule of heat every second. So if the circuit provides more than 1/2 joule of heat to the resistor every second, the resistor would overheat and get damaged. Since the bigger the surface area, the more the heat a resistor can dissipate in a second. Usually the larger the physical size of a resistor, the higher the wattage rating.